Hello, my calculus comrades. My name is Exponential Evan. Thank you, Calculus Christian, for hosting me on your channel today. Today we will be talking about parametrics, but before we get into that, I would like to invite everyone to join Interact Club at EHS. It is a great club. Give back to the community. Thank you. All right, so what parametrics basically is that you have the position of x over time and the position of y over time in different functions. And with this, you can plug in certain times, and then you'll see where the x is and you'll see where the y is at that time instead of it all being in one function. So what I like to do first is take the derivative of, I'd like to find dy dx in this situation, which is pretty simple. You take the derivative of x according to time, and you get the derivative of y according to time. So right here I got, for dx dt, we got 3 cosine 3t, and for dy dt, we got 15t plus 18. And to get dy dx, you do dy dt over dx dt, and the dy dt's will cancel out, so that you only have dy dx left over. And with this problem, the 15t plus 18 and 3 cosine 3t from the derivatives, we can cancel out a 3 from this, and you'll get the dy dx equals 5t plus 6 over cosine 3t. Now this is basic calculus here. Now we'll move on to the second derivative, which is a little bit harder. So with the second derivative, you take the derivative of dy dx, but you also add on an extra dx dt on the bottom. You divide by an extra dx dt. This is because you have to cancel out the dt's, otherwise you'll just have dt left over. And so with this, we have to do the quotient rule with dy dx, and you'll get 5 cosine 3t minus 5t plus 6 times negative 3 sine 3t all over cosine 3t squared. And all of this is over 3 cosine 3t because it has the dx dt. And with a little bit of just basic algebra here and working it out, you'll get 5 cosine 3t plus 3 times 5t plus 6 times sine 3t all over 3 cosine 3t cubed. Another important piece of parametrics is finding the arc length. And with that, we have L, which stands for arc length, is equal to the antiderivative from time 1 to time 2 of the square root of dx dt squared plus dy dt squared. And this equation looks very similar to the Pythagorean theorem because of x squared plus, if you think about it, a squared plus b squared, take the square root, that's how you find c. Now, I would like to show an example problem. We'll start off with x of t equals 3 root t minus 7t, and y of t equals ln of t. Doing some just basic calculus, we get dx dt equals 3 over 2 root t minus 7, and dy dt equals 1 over t. Now you can just basically just plug these numbers. Oh, sorry, I forgot. We're doing it from time 1 to 9. So we'll plug those in the respective slots, and you just basically just plug it in. Antiderivative from 1 to 9 of the square root of 3 over 2 root t squared plus 1 over t squared. And at this point, I'd recommend using a calculator, because otherwise it looks really ugly. And yeah, so with that, we get 50.075 as the arc length, which would be in units. And yeah, just use a calculator for this problem. A lot easier.